Hi everyone. I thought we could go through assignment number 25, trig graphing and inverses review for our test that's coming up. Number 1 says y equals 3 cosine pi x minus 2. And the question is, what's the period and the amplitude? And then we're supposed to graph one period of this. Well, that number is the amplitude. Remember, amplitude is always positive, so if there were negative here, amplitude is 3. Amplitude is 3, and remember, for period, we do 2 pi over our b value. Our b value here is pi, so 2 pi over pi gives me 2. Period is 2, and the amplitude is 3. Okay, and we're supposed to graph one period of this. So we set the argument equal to 0 and 2 pi for cosine. So pi x equals 0 and pi x equals 2 pi. We'll divide both sides by pi in each equation. And we'll get x equals 0 and x equals 2. So here's 0, here's 2. We need to find our quarter points. So first halfway, and then halfway between 0 and 1, and halfway between 1 and 2. Okay, we've got our quarter points. Now it's a cosine function, so we're going to start with a positive cosine. So we're going to start high, go to the midline, down to the bottom, and then back up again. Please pay attention to concavity. Concave down, concave up, and concave down. Okay, next we're supposed to label our midline, our sinusoidal axis. So this is y equals -2. The amplitude we said was 3, so 3 plus -2 is 1. And -2 minus 3 is going to be -5. So there's number 1. Okay, let's take a look at number 2. Number 2 says y equals -1/2 sine 1/3 x minus pi over 3 plus 1/4. Okay, so we know the amplitude is 1/2, not -1/2, positive 1/2. The amplitude is always the absolute value of this number. Okay, so amplitude is 1/2, and the period, well, we want 2 pi over 1/3. That's the same as 2 pi divided by 1/3, or 2 pi times 3 over 1. So 6 pi is our period. Okay, we'll start graphing by finding our starting and ending points for one period by setting this argument. 1/3 x minus pi over 3 equals 0, and 1/3 x minus pi over 3 equals 2 pi. So we get 1/3 x equals pi over 3, and if I multiply both sides by 3, I get x equals pi for our starting point. This is 6 pi over 3 plus 1 pi over 3 is 7 pi over 3. So 1/3 x equals 7 pi over 3. And if we multiply both sides by 3, we get x equals 7 pi. So we're starting at pi, and we're ending at 7 pi. So this is pi, this is 7 pi. Halfway between is going to be 4 pi, because I did 1 pi plus 7 pi divided by 2. That's 8 pi over 2, or 4 pi. Here, halfway between these two, is going to be 1 plus 4, 5 divided by 2, so 5 pi over 2. And here we're going to have 11 pi over 2. Okay, this is a sine graph, and it's a negative sine graph, so it starts on the midline, goes down, back up to the high point, back to the midline. Concave up, and then concave down. Now, we know that this is y equals 1/4 here. we go down 1/2 from there. So we want to do 1/4 minus 1/2. And that's going to give me 5 pi over 2 negative 1/4. And for this one, we're going to go 1/4 plus 1/2. 1/4 plus 1/2 for positive 3/4. So 11 pi over 2 comma 3/4. All right, there's number 2. Let's take a look at number 3. 3 says y equals negative 4 sine x plus pi over 2. Well, we know that the amplitude here is 4, and we know that the period is 2 pi over 1 because our b value is 1. So our period is 2 pi. Now, what about our graph? Well, we'll do x plus pi over 2 equals 0. And that will give me x equals negative pi over 2. And we'll do x plus pi over 2 equals 2 pi. And when we subtract pi over 2 from each side, we'll have x equals 4 pi over 2 minus 1 pi over 2, or 3 pi over 2. So negative pi over 2, 3 pi over 2. Halfway between these will be 1 pi over 2. Halfway between negative pi over 2 and positive pi over 2 is 0. And halfway between pi over 2 and 3 pi over 2 is pi. It's a negative sign graph, so it starts on the midline, goes low, back up to its high point, and then back to the midline. Concave up, concave down. Okay. And we know that this is y equals 0 because there's no d value to consider. So we just need to go up 4 and down 4. We're going to go down 4 and have 0, negative 4. We're going to go up 4 and have pi, positive 4. And there's our graph of one period for number 3. Okay, number 4. We don't have to worry about the amplitude and period. We're just graphing one period for each of these next 10 problems. I guess it's 11 problems. We've got y equals negative 1/2 sine 6x plus 5 pi. Okay, so 6x plus 5 pi equals 0. 6x equals negative 5 pi. X equals negative 5 pi over 6. And 6x plus 5 pi equals 2 pi. That's going to be, when we subtract 5 pi from both sides, 6x equals negative 3 pi. And if we divide by 6, we get x equals negative 3 pi over 6. Now I know I can reduce this fraction, but since I can't reduce this one, for the purposes of finding quarter points, I'm actually going to leave that alone and not reduce it. Okay? So we've got negative 5 pi over 6 on one end and negative 3 pi over 6 on the other. Well, halfway between negative 5 and negative 3 is negative 4 pi over 6. But we could always do negative 5 pi over 6 plus negative 3 pi over 6 and then divide by 2. Since the denominators are the same, we could add the numerators and double the denominator, or add the numerator and divide by 2. And that gives us this. So now we want to find halfway between negative 5 and negative 4. Well, if I add those together, I get 9. And if I double the denominator, I get 12. So negative 9 pi over 12. And here, if I add these, I get negative 7 over 12. And this makes sense because this one would be negative 8 pi over 12, and this would be negative 10 pi over 12. So negative 10, negative 9, negative 8, negative 7, negative 6 pi over 12. So this is fabulous. We've got a negative sign. So we start on the midline, go down to the bottom, back up to the midline, up to the top, and back to the midline. There's our graph. The d value again is 0, so y equals 0 here. We're going to have negative, and if you want to reduce this, you can at this point. 3 pi over 4, comma, negative 1/2. And over here, 7 pi over 12, comma, positive 1/2. And there's problem number 4. Okay? Let's take a look at 5. Ooh, 5 is a tangent. Y equals tangent pi x over 3. Remember, we set this argument not equal to 0 and pi for tangent. We set the argument pi over 3x equal to negative pi over 2. And we set the argument pi over 3x equal positive pi over 2. And this doesn't tell me starting and ending points per se, it tells me where the vertical asymptotes are for one period of tangent. So if I multiply by 3 over pi, I get x equals negative 3/2. And if I multiply by 3 over pi, I get x equals positive 3/2. So my graph then has a vertical asymptote here at negative 3/2 and a vertical asymptote here at positive 3/2 and tangent graph shape, no shift up, so we know that this is just halfway. This x coordinate is halfway between these two. Well, halfway between negative 3/2 and positive 3/2 is 0. So this is just 0, 0. All right, that's my graph. That was number 5. Let's take a look at 6. 6 is a negative cosine. Y equals negative 4 cosine x plus pi over 2. Okay, so I set the argument equal to 0 and 2 pi for cosine. X plus pi over 2 equals 0. So x equals negative pi over 2. And x plus pi over 2 equals 2 pi. So if I subtract pi over 2 from both sides, 4 pi over 2 minus 1 pi over 2 gives me x equals 3 pi over 2. So our graph starts at negative pi over 2 and ends at 3 pi over 2. Halfway between is positive pi over 2. Now I need to find the quarter points. Halfway between negative pi over 2 and positive pi over 2 is 0. But you know, you could always do negative pi over 2 plus pi over 2 over 2 and end up with the same thing. Halfway between pi over 2 and 3 pi over 2 is 2 pi over 2, also known as pi. This is a negative cosine graph, so we start low for negative cosine, go up to the midline, go to our high point, and then back down again. Remember, we should be concave up, concave down, concave down, concave up. Now, what about our d value? Well, our d value is 0 again. Our amplitude is 4, so this is going to be negative pi over 2, go down 4. And this is going to be positive pi over 2, go up 4. And this is going to be 0, 3 pi over 2, go down 4. And there's my graph for number 6. 7. 7 is a cotangent. Ooh, a negative cotangent. Y equals negative cotangent 7 pi over 4 plus 7 pi over 4. Oh, no, that's an x, not a pi. And that's it. Well, remember, we set the argument equal to not negative pi over 2 and pi over 2 like we did for tangent, but we set the argument 7x over 4 plus 7 pi over 4 equal to 0, and 7x over 4 plus 7 pi over 4 equal to pi. Remember, the period for cotangent and tangent is pi. The distance between these endpoints is pi. So let's subtract 7 pi over 4. 7x over 4 equals negative 7 pi over 4. And multiply by 4/7, and we get x equals negative pi. And now here, this is 4 pi over 4 minus 7 pi over 4. So 7x over 4 equals negative 3 pi over 4. And then when we multiply both sides by 4 over 7, we get x equals negative 3/7 pi. Don't lose that pi. Okay, so negative 7/7 pi and negative 3/7 pi. Negative 7/7 pi, negative 3/7 pi. And you may be saying, well, why did you bother turning negative pi into negative 7/7? Well, I need to find the place that's halfway between these two vertical asymptotes. And I know, thanks to Ms. Rowan in the 7th grade, that if one of my numbers is a fraction, then I need to make a common denominator in order to add these together and divide by 2. So we're going to end up here with this inflection point at negative 5 pi over 7. Now, there's no d value, so we know this is 0 here, or is it? Yeah, there's no d value, so that's 0. Now, what about the shape? Well, cotangent normally looks like this, but we have a negative cotangent. So remember, negative cotangent is going to be a reflection of cotangent, and so our graph is going to look like this. Okie doke. There's number 7. Number 8. Finally, a d value. 8 says y equals cotangent 3 pi x over 5 minus 2.5. Okay, so 3 pi x over 5 equals 0, and 3 pi x over 5 equals pi. So if I multiply both sides by 5 and divide both sides by 3 pi, these cancel, and I get x equals 0. Here, if I multiply by 5 over 3 pi, 5 over 3 pi, these cancel, I get x equals 5/3. So I have a vertical asymptote at x equals 0, and a vertical asymptote at x equals 5/3. This is a cotangent graph, so here's my characteristic shape. And halfway in between these 2 points, we'll have our inflection point where we go from concave up to concave down. We know the y value of that inflection point is our d, so that's negative 2.5. Now what about this x value? Well, x is halfway in between these two. So 0 plus 5/3 divided by 2 is going to be 5/6. Okay, so there's number 8, a cotangent graph that's been shifted down. 9 is a tangent graph. Y equals tangent 2x plus pi. No d value, so I just have to do 2x plus pi equals, remember it's tangent, negative pi over 2, and 2x plus pi equals positive pi over 2. We really need to know these, what we set the argument equal to for each of our trig functions, or we're going to run into trouble. So let's subtract pi from both sides and get 2x equals negative 3 pi over 2, and divide by 2. And so I get x equals negative 3 pi over 4. And here, when I subtract pi from both sides, I'll get 2x equals negative pi over 2. And when we divide both sides by 2, we get x equals negative pi over 4. So our vertical asymptotes are negative 3 pi over 4 and negative pi over 4. It's a tangent graph and it's positive tangent, so that's my shape. And halfway in between these points is going to be negative 2 pi over 4, There's no d value, so this is 0. And that's number 9. Number 10, secant. Y equals secant 4x minus pi over 2 plus 3. Remember, secant is the reciprocal of cosine. So I'm going to start by graphing y equals cosine 4x minus pi over 2 plus 3. That means I set the 4x minus pi over 2 equal to 0, and the 4x minus pi over 2 equal to 2 pi. I'll add pi over 2 to both sides, so 4x equals pi over 2, and divide by 4. So x equals pi over 8. And here I'll add pi over 2 to both sides. 4 pi over 2 plus 1 pi over 2 means 5 pi over 2. And then if I divide both sides by 4, I get x equals 5 pi over 8. So we've got pi over 8 and 5 pi over 8 as our starting and ending points for our cosine graph. Pi over 8, 5 pi over 8, halfway in between would be 3 pi over 8, halfway in between those would be 2 pi over 8, and halfway between these would be 4 pi over 8. I'm thinking about cosines, so I'm starting high, going to the midline, going low, and then back up again. But remember, we're graphing secant, and wherever cosine crosses that sinusoidal axis, I need to draw an asymptote. So pi over 4 is an asymptote, and pi over 2 is an asymptote. And then I sketch in my graph of secant, which is a little paraboloid in here, and half a paraboloid over here, and half a paraboloid over here. This is a quarter of a period, this is half a period, this is a quarter of a period, and together, taken together, this makes one period. Don't forget to label these points. You know that this is y equals 3. Our amplitude is 1, so we're going to go up 1. Pi over 8, 4. And 5 pi over 8, 4. But down here, we've got 3 pi over 8, and we went down 3. I'm sorry, we went down 1, so 3 minus 1 is 2. Okay, so there's our secant graph, number 10. Number 11. Y equals tangent x over 3 minus 2. Okay, so it's tangent, so we set the argument equal to negative pi over 2, and we set the argument equal to positive pi over 2. If I multiply both sides by 3, I get x equals negative 3 pi over 2. If I multiply both sides by 3, I get x equals positive 3 pi over 2. So vertical asymptotes at negative 3 pi over 2 and positive 3 pi over 2. It's a positive tangent graph, so this is our shape. This is halfway in between these x values. Halfway between negative 3 pi over 2 and positive 3 pi over 2 is 0. And the y-coordinate here is our d value, negative 2. So there's number 11. Number 12. Number 12 is a cosecant. Let's take a look at graphing cosecant. We know in order to graph cosecant, we start by graphing the sine version of this problem. So we're going to be looking at y equals 3 sine 2x minus pi over 4. Okay, well, a sine graph, I set the argument equal to 0, and I set the argument equal to 2 pi. I get 2x equals pi over 4, or x equals pi over 8, and 2x equals 8 pi over 4 plus 1 pi over 4 is 9 pi over 4, and so x equals 9 pi over 8. So I'm going to start with pi over 8 and end with 9 pi over 8. Halfway in between is going to be 5 pi over 8. Halfway in between those will be 3 pi over 8. And halfway in between 5 and 9 will be 7 pi over 8. I'm graphing a sine graph, and it's positive sine, so I start on the midline, go up to the max, down to the midline, back down to the low, and then back to the midline. So there's my sine graph. But remember, I'm really trying to graph cosecant, so wherever sine is equal to 0, cosecant is going to have a vertical asymptote. And don't forget to draw in the shape for cosecant, which is 2 complete paraboloids, one for this half of the period and one for this half of the period. Please don't do this. I find this really annoying. These are asymptotes. I need to approach these. If you draw this, I don't think you know you're supposed to approach these asymptotes. So please approach the asymptotes. Okay? Now, we still need to label these points, these high and low points. Well, we know this is 3 pi over 8. And we know the amplitude is 3. So 0 plus 3 makes 3. And over here we have 7 pi over 8. And 0 minus 3 is going to be negative 3. Okay. There's our number 12, cosecant, 3 cosecant. 13. 13, y equals negative 2 secant x over 2 minus 2 pi over 3. So it's secant, it's negative secant, so I'm going to start by drawing the cosine version of this first. I'm going to set the argument equal to 2 pi over 3, 0, and x over 2 minus 2 pi over 3 equals 2 pi. So here I get x over 2 equals 2 pi over 3, and if I multiply both sides by 2, I get x equals 4 pi over 3. Here, this is 6 pi over 3 plus 2 pi over 3, means x over 2 equals 8 pi over 3. And if I multiply by 2, I get x equals 16 pi over 3. So my negative secant graph is going to start at 4 pi over 3 and end at 16 pi over 3. Now halfway between these will be 10 pi over 3. I'm adding these together, getting 20, and dividing by 2. I need halfway between these, 14 divided by 2, and I need halfway between these is going to be 13 pi over 3. Okay, now it's negative secant, so I start low, go to the midline, hop high, and then back down again. This would be my negative cosine. But remember, we're graphing negative secant, so wherever this cosine crosses the midline, we draw in our vertical asymptotes. Those would be at 7 pi over 3 and 13 pi over 3. And then we draw in the shape of our negative secant graph. This paraboloid here, half a paraboloid, and half a paraboloid. We still need to label these points. This one is 10 pi over 3, comma, amplitude is 2. This is going to be 4 pi over 3, negative 2. This is 16 pi over 3, negative 2. And there's our graph for number 13, a negative secant graph. Finally, number 14, the last of our graphing problems. y equals 1/4 cosecant x over 3 plus pi over 3 minus 2. Okay, so I'm graphing sine, because this is cosecant, x over 3 plus pi over 3 equals 0, and x over 3 plus pi over 3 equals 2 pi. I subtract pi over 3 from both sides, I get x over 3 equals negative pi over 3. I multiply both sides by 3, and I get x equals negative pi. Here, I'm going to subtract pi over 3 from both sides. 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. And when I multiply both sides by 3, I get x equals 5 pi. So my graph is going to start at negative pi and end at 5 pi. It's cosecant, so I'm thinking about sine. I need quarter points. So what's halfway between negative 1 and positive 5? 2 pi. Because if I add these together, I get 4. If I divide by 2, that gives me 2. And halfway between 2 and 5 is 7 pi over 2. Halfway between 2 and negative 1 is pi over 2. We're graphing cosecant, so I start with my sine graph. Wherever my sine graph crosses the sinusoidal axis, which in this problem is at negative 2, I draw in vertical asymptotes. And so we have vertical asymptotes at negative pi, at 2 pi, and at 5 pi. We still need to sketch in our cosecant graph. Remember to bend to those asymptotes. Bend to those asymptotes. And label these points. So this is pi over 2. This is negative 2. The amplitude is 1/4. So I'm going to go up 1/4 from negative 2, which is going to be negative 8/4. This will be negative 7/4, negative 1 and 3/4. This one I go down another 1/4, so 7 pi over 2, that's a 7, not a 3. Let's write it nice. 7 pi over 2, comma, negative 2 minus a 4th is negative 9/4. And that's that over pair there. Okay, those are our graphing problems. Let's take a look at these evaluating problems. If we're comfortable with our unit circle, they should go fairly quickly. Number 15 says sine inverse of 1. Remember, the way we read this is what angle within the restriction for inverse sine has an upness of 1. Well, I know sine is equal to 1 at pi over 2, and pi over 2 is within the restriction of negative pi over 2 to pi over 2 for inverse sine. So this is going to be pi over 2. Okay, what about 16? Sine inverse of negative 1. Okay, so what angle within the restriction of inverse sine has an upness of negative 1? Now I might want to say this is where my upness is negative 1. And I might want to say 3 pi over 2, except that's not within the restriction for inverse sine. I have to get here by going negative. This is negative pi over 2. Really need to pay attention to the restrictions for these inverse trig functions. Okay? 17. Sine inverse of negative 1. Well, many students want to just cancel these out and claim this is negative 1. And sometimes that works, and we saw in class that sometimes that doesn't work. So just in case you're not sure about when that works and when that doesn't work, I'm actually going to go the long way. What angle within the restriction of inverse sine has an upness of -1? That would be -π/2. What's the sine of that angle? Well, the sine of that angle, the sine of -π/2, the upness there is -1. So in this case, I could have just canceled out the function of the trig function and its inverse. Let's take a look at 18. 18 is a draw a triangle problem. Tangent of cosine inverse of 4/5. So what angle has a cosine of 4/5? So I'm going to draw a picture. Cosine is adjacent over hypotenuse, and I say this angle does. I use the Pythagorean theorem or my knowledge of Pythagorean triples to find this side as 3. And then I say, okay, what's the tangent of that angle? Well, what's the tangent in this picture? The tangent in this picture is opposite over adjacent, or 3/4. Okay, 19. Cosine inverse of cosine 3π/2. Okay, so cosine of 3π/2 is 0. What angle within the restriction of cosine has an overness of 0? Well, what is the restriction for inverse cosine? It's not the same as inverse sine, -π/2 to π/2. For inverse cosine, we go from 0 to pi. So I'm looking on the unit circle from 0 to pi, where the overness, or x value, is equal to 0. So if I think about my unit circle going from 0 to pi, where on this unit circle is the x value 0? Ah, here it is. Okay, so what angle is this that we're looking at when we look at this angle? And that's π/2. So in this problem, I couldn't cancel these out, because if I did, I would have gotten 3π/2. And our answer is supposed to be π/2. The rule we came up with in class is, if the given angle is outside of the restriction, you can't just cancel. This is outside of the restriction. The problem we looked at before, that wasn't a given angle. So no, there'd be no canceling there. I mean, we could cancel there. It's only when the given angle is outside the restriction that we have to go the long way. Okay, let's take a look at 20. 20 says the tangent of inverse sine of x squared. Okay, so what angle has a sine of x squared over 1? This one does. This angle. All of this is saying this picture. What angle has an upness, or a sine, opposite over hypotenuse, of x squared over 1? I'm going to use the Pythagorean theorem to find this missing side. And now I'm going to say, well, what's the tangent in this picture? Well, tangent is opposite over adjacent. And so I get x squared over square root 1 minus x squared. Okay? Please remember from last semester that this is not this. That's really bad. Don't do that. Right? I could factor 1 minus x, 1 plus x, but I don't have two of the same thing here underneath. Nobody can come out from underneath that radical. Certainly not a 1 minus x. You can't take the square root of each piece because of this. Right? So don't do that. So our answer here, what's the tangent in this picture? Opposite over adjacent, and there's our tangent. That's number 20. 21. Sine inverse of -1/2. What angle within the restriction for sine has an upness of negative 1/2. And a lot of students want to say 7 pi over 6. That's not within the restriction. Most of them want to say 11 pi over 6. That's not within the restriction. Remember, our restriction goes from negative pi over 2 to pi over 2. So this negative 1/2 has to be gotten by going in the negative direction. And so our answer here is negative pi over 6. Okay, 22. Inverse tangent of 0. What angle has a tangent value of 0? What angle has a tangent value of 0? Well, because I know my tangent reference graph, I know that angle. Right? I mean, think about this graph. We've got negative pi over 2. We've got pi over 2. Halfway in between, we've got 0, 0. What angle has a tangent value of 0? Tangent value of 0 happens when the angle is equal to 0. So 0 is my answer for number 22. 23. Cosine inverse negative root 3 over 2. What angle within the restriction of inverse cosine, which goes from 0 to pi, has an overness, or an x value, of negative root 3 over 2? Well, we know that's 5 pi over 6, because we're comfortable with our unit circle. 24. Tangent inverse root 3 over 1. Well, that's the same as, yeah, I don't recognize that, do I? But if I divide here by 2 and here by 2, I could think of this as sine inverse root 3 over 2 cosine inverse 1 over 2. So what angle has root 3 over 2 for the upness and 1/2 for the overness? And the answer is pi over 3 does. Except this is negative. So what am I supposed to do with that? Does the negative have to go on the top, or can the negative go on the bottom? Well, let's take a look at each of those cases. Here, well, with this one, remember the restriction for inverse tangent is negative pi over 2 to pi over 2. Here, I'm saying what angle within the restriction of inverse sine has an upness of negative root 3 over 2? Well, that would be negative pi over 3. What angle has an overness of 1/2? Ooh, that's positive pi over 3. They're not the same. Sad face. Okay, so what if I apply this down here? Well, now I get this one to be positive root 3. Uh-oh, negative 1/2. That happens at 2 pi over 3. Uh-oh, they're not the same. So what am I supposed to do here? Well, here's the easy rule. You know that inverse tangent and inverse sine have the same restriction. So I'm going to apply the negative to the inverse sine. Remember, we had negative pi over 3. And I'm going to say that. Now, let's test that out. Okay? If this is true, right, we said negative pi over 3 is the angle within the restriction of inverse tangent that has a value of root 3 over 1 or root 3. So what's the sine of negative pi over 3? And what's the cosine of negative pi over 3? Well, the sine of negative pi over 3 is negative root 3 over 2. And the cosine of negative pi over 3, careful, positive 1/2. We end up with negative root 3, just the way we're supposed to. So when you've got that inverse tangent, you can always apply the sine to the sine. Okay. 25. Almost done here. Inverse sine of 1/2. What angle within the restriction of sine has an overness of 1/2? It's sine, so it's an upness of 1/2. That's pi over 6. 26. sine inverse negative root 3 over 2. What angle within the restriction for inverse sine has an upness of negative root 3 over 2? Oh, we just saw that. That was negative pi over 3. 27. We've got the secant of cosine inverse of root 3 over 2. Okay, so cosine inverse of root 3 over 2, what angle within the restriction of cosine has an overness of root 3 over 2? Well, I know that to be pi over 6. So we're asking, hey, what's the secant of pi over 6? Well, what's the cosine of pi over 6? And flip that answer upside down. So the cosine of pi over 6, wait a minute, we already knew that. So if that's the cosine, then the secant of pi over 6 is going to be 2 over root 3. Or if you rationalize, 2 root 3 over 3. So this is 2 root 3 over 3. Or 2 over root 3. Okay, 3 problems left. 28. Says tangent inverse tangent 5 pi over 3. Well, earlier we said we could cancel these out if the given angle was within the restriction. But our restriction is negative pi over 2 to pi over 2. So, no, not going to work. All right, so let's think about this. The tangent of 5 pi over 3. Okay, well, that's the sine of 5 pi over 3 over the cosine of 5 pi over 3. Sine of 5 pi over 3 is negative root 3 over 2. Cosine of 5 pi over 3 is 1/2. And so I end up with negative root 3. Okay, so tangent inverse of negative root 3. Well, when we did this earlier, we had to do this, and then we had to do this, and then we said, okay, that's sine inverse negative root 3 over 2 over cosine inverse root 3 over 2. And this is where we had the conversation about applying the negative with the sign, the negative sign with the sign. And so we had negative pi over 3. So even though our given angle was 5 pi over 3, we needed something that was within the restriction, negative pi over 3. You could also do this problem this way. Here's 5 pi over 3, but that's outside of our restriction because our restriction stops here at pi over 2. And we want, therefore, this angle, negative pi over 3. So our answer to this problem is negative pi over 3. That's 28. 29 is another draw a triangle problem. And then look, there's a word problem. Okay, 29. Tangent cosine inverse root 2 over x. Okay, so I'm going to draw a triangle where the cosine is root 2 over x, or the adjacent over hypotenuse is root 2 over x. Now I use the Pythagorean theorem to find this side. If I'm not sure how to do that, remember a squared plus b squared equals c squared. So root 2 squared plus question mark squared equals x squared. 2 plus question mark squared equals x squared. But we want to solve for question mark. So question mark squared equals x squared minus 2. And then we take the square root of both sides. Notice I'm taking the square root of the whole side, not each piece, right? This is not going to be x minus root 2. That would be bad, bad, bad. Instead, question mark is equal to the square root of x squared minus 2. So this is square root x squared minus 2. And now we want to know what's the tangent in this picture. If this is the angle whose cosine is root 2 over x, What's the tangent of that angle? The tangent is opposite over adjacent. And so this is going to be root x squared minus 2 over root 2. If you feel compelled to rationalize here with root 2, you'd end up with root of 2x squared minus 4 over 2, because root 2 times root 2 is 2. But I'm okay with this answer for us. Okay. All right, last problem. Sadly, I released my helium balloon I was holding in order to set it free. Bye, balloon. I turn my back and mope away. When I get 50 feet away, I turn around for one final look at my balloon. So here's the balloon floating away. This is 50 feet away. This is me. I look back at my balloon. I lift my head to see the balloon. Now this makes me think of math, and suddenly I'm in my happy place. Write a function for the angle of inclination of my neck, theta. There's theta in terms of the height of the balloon, x, when I'm 50 feet away from the point below. Well, if I think about this as a trig function, I see opposite and adjacent. And I want to say that tangent of theta equals x over 50. But be careful. This says a function of theta. Write a function of the angle of inclination in terms of x. So I need to solve for theta. And to do that, I take the inverse tangent of both sides. Theta as a function of x. Tangent inverse x over 50. Yes, I have to take the inverse tangent of both sides. And no, there's nothing more. This is it. This is the answer. But you can't leave your answer here. The grammar of the question says, write theta as a function of x. Theta as a function of some x stuff. Not tangent theta as a function of x. Theta as a function of x. I have to get theta by itself here. So there's number 30. Yay, we're done. Okay, I hope you found this useful, and I will see you in class.